Our next chapter is Physics, Chapter 4, Energy. It is a very easy, very simple chapter, some new concepts which are very interesting. So, we are going to have a little discussion uh, and go ahead. Okay, let's start. So, Unit 1 is about energy and work. So, in everyday life, we use these terms energy and work. Okay. For example, when we play and we get tired, we say that we are left with very little energy or we have spent our energy. When we do a lot of work, a lot of homework basically, we say that we are tired and we are feeling like we are having low energy. So basically, to do more work, we need to spend more energy. If we do more work, we are spending more energy. So there is a direct relationship between work and energy. Okay. So work done on a body in changing its state is to be the energy possessed by the body. Please note this down. This is important. This is accordance with physics, not with your mental work, but physical work. Work done on a body in changing its state. What is this state? Solid, liquid, gas? No, 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 no. The state which we are talking about over here is the state of rest or state of motion. So if you want to change the state of a body from rest to motion, you have to do work on it. And the work which you do on the body to change its state from the state of rest to state of motion is stored in that body as energy. And then we say that the energy possessed by body is this much. For example, if a body is taken from the ground to a certain height, then the work is done on the body against the force of gravity. And body at this height possesses energy in the form of potential energy. In the same way, when a body is made to move from rest position, work is done on the body and the body is in motion. So we can say that it possesses energy in the form of kinetic energy, which is equal to the work done on the body. Okay, so always remember when you do work on any body, some energy is always stored in that body, whether it is potential energy or kinetic energy. We are going to talk about what is potential and what is kinetic energy in detail in this chapter ahead. Let's go ahead. So the first definition which you must note down here is the definition of energy. Ability to do work is called energy. Please note it down. Okay. Now, if ability to do work is energy, what is work? Suppose the first example, let's say a boy is preparing his lesson. You know what is this? This is mental work. And in physics, mental work has no place. We do not recognize mental work in physics, even though it needs energy. It needs energy. If you want to watch this video, if you want to take notes, if you want to do homework after watching this video, you will require some mental energy. Yeah? If you are mentally tired, you cannot do all this work. Yes, this is work, but this is mental work. And mental work has no place in physics. It is not recognized in physics. Physics only recognizes physical work. So, what is physical work? For example, when a boy kicks a football, he is doing physical work. When a porter, like coolie, carries a load for you, he is doing physical work. When a car or bus moves, it does mechanical work, which is also physical work. Right? So, work can only be termed as physical work which causes some kind of motion or displacement. वर्क तभी हम बोल सकते हैं कोई कोई भी बॉडी वर्क कब कर रहा है हम तभी बोल सकते हैं जब उसमें कोई डिस्प्लेसमेंट प्रोड्यूस होता है so without displacement it cannot be termed as work done. So always remember, without displacement work will be zero. If in physics work is to be done, It is said that work is to be done. That means displacement has to happen. Without, let me write here for you, without displacement. Displacement means motion, motion of a body from one place to other place. Without displacement, there can be no work done. Without displacement, there can be no work done. Okay, for work done, displacement has to be there. Now, when you're doing homework, is it any displacement happening? तुम अपनी जगह से हिल रहे हो या तुम्हारी बुक अपनी जगह से हिल रही है? नहीं, you are not making any displacement happen, right? So there is no displacement, although you are doing mental work while doing homework, but it is not recognized by physics. Physics बोलता है कि you are doing zero work. ठीक है? So please don't get offended by physics. Physics को सिर्फ displacement से मतलब है. हाँ, तो while you are playing football and when you kick a football, you are doing physical work. So that time physics will recognize कि हाँ work done हुआ है. देखो यहाँ पे एक बहुत अच्छा डेफिनेशन है वर्क डन का. एनर्जी का तो डेफिनेशन हमने दे दिया. एनर्जी इज द एबिलिटी टू डू वर्क. वर्क डन का क्या डेफिनेशन है? सो अकॉर्डिंग टू फिजिक्स द डेफिनेशन ऑफ वर्क डन इज when a force causes displacement in its own direction, work is said to be done on the body by the force. When a force causes displacement in its own direction, work is said to be done. For example, if you are carrying your school bag on your back and standing, you are not doing any work. See, this is not mental work, this is physical work. But what is the problem here? Why you are not doing work? You are carrying that school bag on your shoulders. You are getting tired. Then why you are not doing work? Because you are not making any displacement. You are not changing your position. So you're just standing with the bag, right? Now the force applied by you on the bag is not making the bag move in its own direction. ठीक है? वो बैग को मूव नहीं कर रहे हो तुम क्योंकि तुम एक जगह ही खड़े हो. Similarly, if you push a wall and it does not move, then no work is done. Pushing a wall, you get tired, but since there is no displacement, no work done. So no matter how much energy you spend in doing all these tasks, but you are not doing any work unless and until there is a displacement on the body in the direction of force applied. Okay, so on the other hand, if you apply force on a heavy box and it moves, then work is done. Similarly, when a cartman or bullocks pull a cart such that the cart moves in the direction of applied force, then work is done. Some cases, force applied does not produce displacement of a body. Instead, the body gets deformed. जैसे inflated rubber balloon. अगर उसको squeeze करेंगे तो displacement नहीं होगा, वो deform हो जाएगा. ठीक है? In the direction of applied force, the balloon gets deformed. Then also we can say that work is done. So if a force deforms a body or produces displacement in a body in its own direction, then we can say that work is done. Factors determining work. कितना work done हुआ है? बहुत ही सिंपल फॉर्मूला है. वर्क डन दो चीजों पर डिपेंड करता है. ठीक है? वर्क डन डिपेंड्स ऑन टू थिंग्स. वन इज द फोर्स अप्लाइड. नंबर वन, कितना फोर्स तुम अप्लाई कर रहे हो उसके ऊपर वर्क डन डिपेंड करेगा. ठीक है? सेकेंड थिंग द वर्क डन डिपेंड्स ऑन, that is the displacement. How much displacement is this applied force creating? ठीक है? यहाँ पे एक एग्जाम्पल लिया है. कंसिडर अ बॉक्स फिल्ड विथ स्टोन्स. Let the box be displaced by 2 meters from A to B by some force. Some work is done in moving the box because force apply किया, displacement हुआ, work done हुआ. If the same force is used to push the box so that displacement is 4 meter, the work done will be double the work done हुआ है. क्यों? क्योंकि displacement double हो गया. So we can conclude that more the displacement, more the work done. more the displacement, more the work done. तो सबसे पहले work done on the body, work done by a body depends on the force applied. More the work done, more is the force applied, and more the displacement, more is the work done. Force और displacement ये दोनों चीज़ों पे work done depend करता है. So mathematically अगर work done की definition हम निकालें तो work is defined as the product of force and displacement through which the force acts. तो वर्क डन का जो सिंबल है वो है W, फोर्स का सिंबल है F, डिस्प्लेसमेंट थ्रू विच द फोर्स एक्ट्स का सिंबल है S. डिस्प्लेसमेंट का सिंबल S होता है, प्लीज याद रखना. ठीक है. सो वर्क डन का मैथमेटिकल फॉर्मूला क्या है? W इज इक्वल टू F इंटू S. Work done is equal to force times displacement, the product of force and displacement. Please remember this formula, you will get some numericals based on this. From the above expression of work, it is clear that if a force does not cause any displacement, that is, if the displacement is zero, then work done will also become zero. Why? Because W is equal to F into S. अगर S ही zero है, तो anything into zero becomes zero. ठीक है. Furthermore, if the displacement caused by a force is at right angles to the direction of applied force, then the work done is again zero. And then in this case, actually this is a special case which you will study in higher classes, but let me give you an example. Suppose there is a man. ठीक है. This man is carrying a heavy load in his heavy box in his hand, heavy load in his hand. Okay. And this man is moving in horizontal direction with this box. Now this box has some weight, so that weight is acting in vertically downward direction. So this is the direction of weight. That is nothing but a force, gravitational force. Okay. And this is the direction of displacement, weight or force and displacement. So what is the angle between the force and displacement here? The angle between force and displacement is 90 degree. Angle between force and displacement is 90 degree. Okay. And therefore work done by the force therefore work done by the force equals to 0. So remember, always remember, whenever the angle between force and displacement is 90 degree, the work done by the force is 0. Now this is a special case, and you will say that, sir, there is displacement and there is force, then why is the work done 0? Because of this angle. And you are going to study this in class 10th, I think. Yeah, not in class 9th, but in class 10th you are going to study this, that why is the work done 0 where there is force and displacement both. That is because of the angle. Let me show you one more example. Now imagine that moon is moving around earth. This is earth and this is moon. Okay. There is a force of attraction towards the center, that is due to gravitation, that is known as centripetal force. ठीक है, ये सब नए नए terms बता रहा हूँ मैं तुम्हें, but it's important. And the direction of motion of moon is 90 degree to the direction of this force. This is the force of attraction This is the direction of motion or displacement. Okay, what is the angle between them? The angle between these two quantities is 90 degree. Here also you can say that work done by Earth on Moon is zero. Although there is force of attraction and although there is motion, there is a displacement. But still the work done by Earth on Moon is zero. Why? Because the angle between the direction of force and direction of displacement is 90 degree. So the angle, whenever the angle between displacement and direction of applied force is 90 degree, the work done becomes zero. The question still remains, why? Why does this happen? And I'm telling you the answer to this question you will get in class 10th when you have already studied trigonometry. Because you have not studied trigonometry, so you will not understand the concept behind this. It is little too early for me to explain you this concept right now, but right now just have this information in your mind. Okay, that's what they are, the examples which they are giving over here suggests. Consider you are carrying a heavy school bag on your shoulders and standing still. The weight of the school bag is acting vertically downward. To counter this weight, your shoulder apply an equal and opposite force in vertically upward direction. Due to this force, there is no displacement. Thus, in the language of physics, you are not doing any work. Furthermore, this is important. So, first example you have understood earlier also, because there is no displacement, there is no work. But furthermore, if you start walking on the flat ground, then the displacement is caused at right angles to the direction of your movement. मतलब ये जो डायरेक्शन है वो तुम्हारे मूवमेंट का है और फोर्स नीचे की तरफ एक्ट हो रहा है, इन दोनों के बीच का एंगल 90 डिग्री. यहाँ पे थोड़ा सा सेंटेंस में गड़बड़ है. देन द डिस्प्लेसमेंट कॉज्ड एट राइट एंगल्स टू द डायरेक्शन ऑफ योर मूवमेंट. If you are walking on a flat ground, displacement and your direction of movement is the same, that is horizontal direction. Yeah, but the force is in vertically downward direction, that is the weight. Okay, so we can say that work done by you against the force of gravity is zero, since distance moved by you is normal to your weight. Normal मतलब perpendicular. ठीक है. in uh, in a way the displacement does not take place in the direction of force applied by your shoulders, hence no work is done. The work will be done only if you start climbing up the stairs or move down the stairs. It is because now the displacement takes in the direction of force. So ये थोड़ा सा complicated है समझना अभी के लिए. So I will suggest कि इतना इस पे मत ध्यान दो, सिर्फ इसको याद रखो कि वर्क डन कब होता है. दिस इज वेरी इंपॉर्टेंट नोट. रिमेंबर, फॉर डूइंग वर्क two conditions are necessary. First, there must be a force acting on the body, and the body must move in the direction of applied force. तो बॉडी को सिर्फ फोर्स के डायरेक्शन में मूव करना है. Okay, so now we know that when a body can do work and when it cannot. Okay, let me summarize this finally so that uh, your final doubts are cleared about when the work is done and when the work is not done. Let me just write when the work is not done. Work done is zero if, number one, there is no displacement. If there is no displacement, no work is done. There is no force. If there is no force, there is no work done. And third, angle between force and displacement is 90 degree. If one of these three condition is there, that means work done is 0. Okay, so always remember, if one of these three conditions occur, work done will become 0. Otherwise, you can find the work done by the formula W is equal to F into S. This is the formula for work done. Okay, so what is the unit of work? Because work is a measurable quantity, right? So we can measure it. So it has to have some unit. The SI unit of work is joule, named after a scientist, physicist. Okay, so joule. When force of 1 Newton causes a displacement of 1 meter in its own direction, then work said to be done is 1 joule. When any body experiences a force of 1 Newton and it moves by 1 meter, then the work done on that body is 1 joule. So 1 joule is 1 Newton times 1 meter. Remember that. This is the definition of 1 joule. 1 joule is equal to 1 Newton meter. Okay. There is a small numerical problem here. Calculate the amount of work done when a force of 25 Newton displaces a body through 10 meters. So we have force and we have displacement. So there has to be work, and work is equal to force times displacement, that is 25 times 10, that is 250 joule is the work done. Very simple. So we are done with the first part of the chapter. Exercise 4.1 is a really simple exercise. There are some study questions, some numericals, and most of it is the objective type question, which I think you should pay greater attention to, because your school test will be objective type only. Okay, so yeah, and of course the assessment test will have numericals and theoretical questions as well, but the small revision test this year, it will be objective type and there will be a lot of objective questions. So please complete this exercise and before your test, of course, and be ready with this part. Okay, so I've explained this part in detail, and we have understood the idea regarding energy and work, definition of work, formula for work, the conditions for work done to be 0. In the next unit, we are going to start with potential and kinetic energy. I'll see you in the next video. Bye bye.